Elon Musk is absolutely convinced we'll be flying in long-distance electric passenger planes in the future. We collaborated with a team of aerospace engineers, NASA scientists, and veteran pilots to sort through the current electric aircraft research and evaluate the most promising new technologies based on performance, practicality, and economics. Firstly, electric motors do not experience power loss from operating at high altitude. Combustion engines, excluding rockets, ingest air from the atmosphere to mix with fuel and burn. We've all heard the maxim that electric cars require less maintenance, and the same can be said for aircraft. Combustion engines are inherently complex machines with thousands of moving parts. Electric motors are fundamentally simple. One NASA study estimated an improvement in efficiency of a modified electric aircraft of 4.8 times compared to an equivalent conventional format in the cruise condition. While Elon Musk might dream of supersonic electric flight, this is likely a long ways off. For the moment, we can't easily achieve the high-speed exhaust of a jet engine using electric power. Right now, propellers are the most practical means for generating thrust from electric current, and our best shot at getting a serviceable electric aircraft into commercial operation. When you think about innovative flying machines, one name comes to mind. So it's no surprise NASA is developing the experimental X-57 Maxwell to test the limits of electric aircraft propulsion. The X-57 will feature a distributed electric propulsion system consisting of 14 electric motors mounted on the wing's leading edge.
We can make our wing very small and optimized for high-speed, very efficient flight.
Despite these advantages, electric aircraft have one major drawback that many believe is insurmountable: